So there we go. Recording starting now. We have this. That is great. Couple things just before we do get started. If you're not familiar with it, we do have some interesting things happening for those of you that use the Wings program. There is actually, it's the second year we've done it, a sweepstakes challenge with $10,000 worth in prizes that is being offered to those people that complete the Wings program. You can find out a little bit more about it by the mywingsinitiative.org. But basically what it comes down to, if you're an instructor that's doing training for a Wings program, or you're a pilot that's maintaining proficiency and currency through the Wings program, when you achieve a level of the Wings, you basically can enter in a sweepstakes entry for each and every level of Wings that you do. So even if you do 5 or 6 of them this year, that can be 5 to 6 entries. And there's going to be 4 $1,500 prizes for people out there. There's going to be 4 $750 prizes and 2 $500 prizes. I'm not going to get into it a whole lot, but that is available out there, and you can find more about it on the mywingsinitiative.org. That's a great thing that actually a safety rep from the New England area with our counterpart, Dan Carter, has set up and done it on a national level. They did a test of it last year. It worked out well, and they're doing it again this year. So tonight, we're going to be talking about what are known as the demonstration stalls and the maneuvers or demonstration maneuvers, which apply to the flight instructor practical test standards, but also should be pervasive throughout all the training that we're doing in airplanes specifically. And we'll talk a little bit about loss of control accidents, testing of flight instructor applicants and the training of flight instructor applicants, what we're expecting of flight instructors versus maybe what is occurring out there. We'll talk about those demonstration maneuvers, or commonly known as demonstration stalls, and how they apply in the practical test standards and the airman certification standards. We'll take a look at what does the GA pilot know about it, and we'll do a quick review of those stalls and the hazards. Total time tonight on the presentation will probably be close to 70 minutes. And what we are talking about tonight, I do apologize for, those rotorcraft type and those that fly other types of aircraft. Most of this is going to be focused on airplanes, but it can be beneficial in other categories of aircraft also. And that's specifically, we actually do see a lot of the same things in glider, especially in light sport airplane, and even in the weight shift control. But when we are talking tonight, most of what we're talking about is things that are associated with training and testing in aircraft similar to these. Now, loss of control is a big issue. It has been on the NTSB most wanted list for a long period of time, and it really is one of the major aspects that leads to GA accidents and even fatalities in it. And we have all sorts of reasons that it can occur, disorientation, distraction. Think of that when we talk about the elevator trim stall this evening. Inappropriate response to an emergent event. We have that with like secondary stalls. Lack of aircraft handling skills. When we talk about the demonstration stalls tonight, all of those deal with that. Risk management, we're definitely going to be talking about that too. Now, this is from AOPA, but where they looked at the last 10 years of all the stall accidents. And it's interesting to note that 20% of all the fatal accidents out there were related to stalls. When we talk about accidents that have a very tragic outcome in general aviation, this is where it's at. And really what we're talking about tonight too is going to focus on these specific areas: takeoff and climb, maneuvering of flight, descent and approach, go around, and landing. And if you take a look, you can see this is the major portion of accidents associated with this, and it's also the major portion of the fatal accidents that we end up dealing with. So I hope that you do pick up a lot of good information to help you be a safer pilot tonight. Now, in the practical test standards, we talk about proficiency, and then there's also demonstration. And this is in the practical test standards for the flight instructor airplane. And when we mention proficiency, what we're talking about is instructional knowledge, the what, why, and how of subject matter maneuvers, and that there is a requirement to do these maneuvers to a specified standard, which is at least at the level you would expect of a commercial pilot. And what we have is, you'll see specified criteria in the practical test standards, or ACS, of heading plus or minus 5 degrees, plus or minus 10 degrees, altitude plus or minus 100, airspeed, minus 0, plus 10, things like that you may remember in your training, or at least I hope you do. Demonstration, what we're looking for is still instructional knowledge, and what we're expecting of a flight instructor when they're doing a demonstration stall or maneuver on a practical test for a flight instructor certificate is they're knowledgeable and proficient at being able to do it. And there's two key components. There's two of them that we focus on. Is we want to see the flight instructor applicant have the ability to demonstrate the maneuver, not necessarily within a specified standard, plus or minus heading, that sort of thing, but we want to see that they are aware of it and can recognize and recover from it as appropriate. And the second thing, which is important for those of you out there that are not instructors and not necessarily looking to become an instructor, but why you should be seeing these demonstration stalls, is educational awareness, is how to show pilots out there what is a risky situation, what can be dangerous to them, and where these scenarios of these dangerous stalls end up occurring and how to avoid those. Now, in reality, we are probably getting down to semantics on it when we're talking about it on a flight instructor practical test. So I'm kind of curious. The first thing we have here is a poll question, and I'm going to go ahead and launch that, John. And we've done this many times before. So I'm going to have to ask you to do the reading, because it's too small for me to be able to see.
Okay, here we go with the poll question. Concerning the demonstration stalls / maneuvers. Select 1. Have heard of them and tried 1 or 2 in my training. All of these are new to me. Found out about them after my training. I am not sure even my CFI knows about them. Or the last one, I have heard of 1 or 2 of them, but that is all. So please make your selection, and we'll let you know what the results are.
And I always do say this, but it is true, vote early, vote often. We have about 72% of you out there, and we have about 300 of you out there. So, we're looking at 210, 220 of you have voted. I'd like to see that remaining 75, 80 out there would be great. And we're passing the 1 minute mark, so I'm going to go ahead and close this here, and then I'm going to share it. And let's see, how are we doing?
Okay, it looks like the #1 selection at 80% was heard of them and tried 1 or 2 in my training.
Excellent, excellent.
Yeah, I think so. That's great. And then the next 2 are at 7% each, and that is all of these are new to me, 7%. Found out about them after my training, 7%. And then we have at 4%, I have heard of 1 or 2 of them, but that is all. And then last but not least at 1%, I am not sure even my CFI knows about them. I'm glad that's at 1%.
Yeah, I am too. And you know what? That's a big improvement. That really is. I'm hiding this. That's our poll question. But this You and I got talking about this subject, it's got to be a couple years ago now, John, I think.
Oh, yeah, yeah.
Yeah. And we asked that very same poll question a little over a year, kind of buried it into a webinar that we did. And this was the results that we got back then. And it led us even more so to say, at some point we have to do outreach on this. Back then we were looking at, only 50% or so of those pilots were familiar with it versus the 80% we have tonight. So I'm glad, I'm very, very glad that we have, some change occurring there, which is excellent.
And we're showing them 290 attendees. Maybe not all of them answered, but certainly if the majority of them did, and 80% are saying they have seen and heard, they have heard of them and at least seen one of them. That's really great, Steve. That's good.
Yeah, that is. And I still have the poll question thing. We had 81% respond out of that. So we had a good turnout. Now, you've probably heard of these. I'm going to call them what a lot of people look at them as, although they don't necessarily have to, because if you know and understand them, you can embrace them. But what some people call the dreaded demonstration stalls. And if you want to find out more, you can see chapter 4 of the Airplane Flying Handbook, because this is where they're all talked about. And there is a copy of that. But we're going to talk later about the cross-controlled stall. We're going to talk about the elevator trim stall, secondary stall, and the accelerated maneuver stall. And I specifically do note the asterisk on the accelerated maneuver stall because with the introduction of the ACS and even the commercial PTS a little bit before that, they had brought the accelerated maneuver stall or accelerated stall back into it. You can also see these are the notes from the 2 Flight Instructor airplane practical test standards. This at the top is the note in that section on area of operation 11, slow flight, stalls and spins for the single engine aircraft. And for slow flight and stalls section on the multi-engine instructor, we have this note associated with it. And we've mentioned that's what the demonstration stalls are. Just for comparison's sake, we'll mention what the proficiency stalls are, the power off, power on stall that we're probably all familiar with. And as I mentioned, in the commercial ACS now, we do have the accelerated stall. With these, what we're really looking at is how good are you at maintaining heading, bank angle, and stuff like that. You got to remember also that these are set to a minimum standard when you're doing these stalls. In your training and proficiency, you should work with an instructor on variations, whether it's doing upset recovery training or unusual attitude work like you see here in this picture, which is very specialized training. You may want to see stalls if you're doing stuff like that. In inverted flight, how does the aircraft behave differently? Take a look at aggravated stalls, or maybe even do something simpler with a flight instructor. If you don't have the capability to do aerobatic instruction, such as doing power off stalls with things like power off recoveries and stall and recovery under the hood, or all sorts of different things. You should not necessarily just focus in on meeting that minimum standard, but you should use these proficiency maneuvers as a way to explore how and why the aircraft flies the way that it does, and to help you understand how and why the aircraft does fly that way. These proficiency training includes practice and exploring your capabilities and limits, all with the safety of a good instructor. If we do take a look, this is power off stalls out of the private ACS. And, you can see all the different things, risk management, the skills. And when we talk about a proficiency stall, such as power off stalls, the big criteria we're looking at a minimum standard are things like, specified heading plus or minus 10 degrees, the smooth transition, establishing a stabilized descent, all of that. You know, note that the demonstration and maneuver stalls, though, are included in this for risk management. You can see in the risk management portion, this is in the power off stalls. They specifically have, for a subject of discussion in doing power off stalls, is secondary stalls, accelerated stalls, and cross-controlled stalls. If you do take a look, this is out of the Flight Instructor practical test standards, and this is what the practical test standards specifically talk about in terms of proficiency in demonstration. You know, as it goes through and it explains the intent of these, you know, tasks B and C, that's power off, power on stalls, is to ensure the flight instructor applicant tested on the proficiency on these tasks needed for pilot certification. And then if you go in and look at what it has to say within the practical test standards for the demonstration maneuvers, is you'll see the intent of task D, E, F, and H. Those are the demonstration ones for single engine, and that's the four we've talked about: accelerated, secondary, elevator, trim stall, and cross-controlled stall. You know, is to make sure that the flight instructor applicant is knowledgeable and proficient in these maneuvers, and this is the important part, can teach them to students for both familiarization and stall spin awareness purposes. When we're doing a flight instructor practical test, we're at least looking at one of these stalls, and we're asking the importance of them and how they would use them with a student at some point in their training to highlight the risk and dangers that could be associated with these stalls and where they might end up occurring. We actually want flight instructors to demonstrate them at some point in a person's training. Now, I do a fair amount of flight instructor practical test standards, and this, if you've taken a test with any examiner, whether it be me or anybody else recently, you probably are aware that we follow a plan of action. It's kind of our checklist of what we do during the flight test. And this is a small little section of my personal plan of action for flight instructor airplane. And one of the things that I always end up asking applicants in the pre-brief is, are they familiar with the difference between the demonstration and proficiency maneuvers? Now, it is a bit interesting, is I usually get one of two reactions in relation to it. I either get that blank stare and that long moment of silence, or, you know, I get a look like this where they're just, you know, oh no, it's all going bad really, really fast. You know, and we've mentioned this too, but I can't emphasize it enough, is in recent years, we've seen that the accelerated stall has been added to the commercial practical test standards in the ACS. When that first happened, I know a lot of examiners dealt with it. I even dealt with it some where, you know, they asked, okay, let's go ahead and do an accelerated stall. And, you know, from over in the left seat, you'd get this look like a what? What are you talking about? And still, every now and then I get some examiners, you know, that are calling me and telling me that, you know, XYZ flight school or XYZ instructor might be a little bit challenged because their student just is completely unaware of what an accelerated stall is. And really, at the commercial level, they should have already seen at least one and discussed it with their flight instructor in their training for sport, recreational, or private pilot. Now, I've been using the terminology PTS, Practical Test Standards, and ACS, Airman Certification Standards, because we are in the middle of that transition. And I had in time past seen drafts of the Flight Instructor ACS, but we're probably coming up this summer, is my assumption. I emphasize that. we're probably going to see a draft come out on the instructor ACS. And as I've been poking around, trying to find out as best as I can, I think we're probably definitely still going to see these demonstration stalls in that new ACS. I don't think they're going away at all. How are we doing on questions, John? Good?
It's been a little bit quiet,
Oh.
Steve, which is fine. I shouldn't say that because everybody will just start throwing questions at us. It's been kind of nice.
Yeah.
Yeah,
Okay.
but we're doing fine so far. I'll let you know.
Okay. Many times we have somebody jumping in with a question by this point in time, and I hadn't heard any of it. So I was like, you know what? Let me just double check with you. So as we get into the demonstration stalls, here's some things you want to consider. Now, how a stall behaves and how the aircraft reacts to it is very dependent upon many different variables. And this is a list, but it's not a comprehensive list on different factors that makes a stall, and maybe even correspondingly a spin, behave the way that it does. Is all of these different things before or as you're approaching the stall, if your rate of onset, if you approach it very slowly versus very quickly, i.e. accelerated stall. Configuration, flaps up, flaps down, dive brakes out, dive brakes in, slats down, slats up. Atmospheric, believe it or not, an aircraft will feel and behave differently if with a very, very high altitude stall than say down at the lower, more dense atmosphere. Of course, we probably all know this. This is part of our spin awareness training, but the coordination and control displacement, as you approach the stall, and power, what you have, aircraft loading, weight, center of gravity. And even after the stall occurs, all of these have impacts on how and why a stall will behave the way that it does. Power, pilot input, configuration, of course. And then we start to get into gyroscopic and aerodynamic forces. These are all great things to explore, at an unusual attitude recovery course, or get into doing some aerobatics and a well-qualified instructor and a very capable aircraft. You'll learn all sorts of things that have an impact on the aircraft that you didn't even realize was there before. Control position, maybe pilot induced, maybe not. That's something to also recognize because, depending upon how deep of the stall you've gotten into, the actual angle of the relative wind, all of that can have different displacements on a control position, and duration, how long you stay in the stall. All of that, this is a partial list, and I always add to this list, and I say it jokingly, but there's a lot of truth behind it, is one of the major pre-stall variables is your flight instructor fidgeting, or what flight instructor harassment of, oh, watch it, you're getting there, oh, close, watch out, up. That definitely is something that has an impact on how we behave with the stalls. And for the flight instructors out there, remember, a major part of learning is experiences through the senses. And this is some of what you should be doing in teaching stalls and spin awareness, is allowing the student variations in this and looking and seeing and exploring what the effects are, like these pre-stall variables and these post-stall variables. Your job as the instructor is kind of what I call pulling that string on the student to draw out those experiences, as, hey, we just did a stall, with this amount of power and this configuration. What did you notice about it? Did you specifically notice maybe a change in the airspeed if you did the 1 knot per second deceleration up to it? Or, did you notice this? Did you notice that? That's what we're looking at. Now, the cross-controlled stall. This is where we'll get into kind of in depth on each of the 4 different demonstration stalls. The first one we'll talk about, and I don't think it's in any particular order. Maybe it is the same order that it's in the airplane flying handbook. I don't recall. But a cross-controlled stall occurs when the critical angle of attack is exceeded with the aileron pressure applied in one direction and rudder pressure in the opposite, uncoordinated flight. A skidding cross-control stall is most likely to occur in the traffic pattern, so forth and so on. Base to final, we're probably all familiar with that. And here's actually, this is for the glider types out there, but this is a good video. The Soaring Safety Foundation has a bunch of trigger videos, both on their website and out there on YouTube, where you can play them and use them as a way to discuss what's going on. So I'm going to go ahead and play that. It'll take a second. At least this tends to work much, much better. About 95% of you should be able to see this. That's kind of an interesting little video there. There's multiples out there on YouTube that you can use, but that's Soaring Safety Foundation has some of these trigger videos, and they have that one specifically on the cross-controlled stall. I will specifically note, this is for those that are watching the recording at a later date, later time, is the videos that are played in this format in the recording you will not be able to see, but where I can, I have put the web address so you can find them on your own. You can do the old screenshot trick or type the items in. And we want to be aware of what we end up doing in relation to flying and all of this. And I bring this up, this is kind of a little bit of a segue from a safety perspective. If you're doing more dynamic maneuvering, you want to assure yourself that you're doing it in an appropriate aircraft and also with an appropriate instructor. This is actually some video from spins that I had done at a previous work establishment that was used in some video training and doing some cross-controlled spin. So that's what a cross-controlled entry and spin in a Cessna 152 looks like, which is a terrific little training aircraft and has had it. But my safety aspect to this is I just want to point out, this is that same aircraft a few years later. And this is, kind of my safety caveat to it. Believe it or not, that same aircraft was in a fatal accident that ended up being a very prominent accident that led to an airworthiness directive that put limitations on the Cessna 150, 152s unless the larger rudder horns were installed on it. This was an instructor and a student out doing spins, and the rudder horn ended up getting locked over on the stop bolt. We had a fatal accident in Canada that was a result of it. That is the probable cause associated with this accident in that particular aircraft. So, I just want to emphasize from a safety perspective, do assure yourself that you're out there flying an aircraft that is qualified to do what you're doing, and also you're getting very good instruction associated with it. The next type of stall that we look at on the demonstration ones, we just looked at the cross control, is the elevator trim stall. And this is what is labeled in the airplane flying handbook. Basically what we're looking at is setting ourselves up and doing an approach to landing, having it trimmed, configuration for landing, trimmed for airspeed. I myself, when I do these with students, I usually ask them to set it up for a short field landing. That way they're at the largest flap setting and most likely very close to the most nose up trim that they can be at. In fact, they're probably pretty darn close in a single engine airplane to full nose up trim. And then deciding to go around for whatever reason it may be. It may be that you had a hard landing and bounced. It may be, the classic deer runs out on the runway, or the runway has not cleared soon enough. And what happens is as you add that power to simulate the go around, the nose starts pitching up significantly. And it'll vary in different aircraft with it, but looking for that. And the other thing that I point out to students in this is if they're distracted enough that they're letting the nose pitch up too high, that they're probably also distracted enough in the airplanes not to be applying that right rudder. Now, what we want to do is point out to them the dangers on how quickly that nose rises up and approaches a stall, and also how quickly, you know, the aircraft can be in that situation that it is just not coordinated due to the power and left turning tendencies of the aircraft. So, you know, at some point we should go ahead and practice this with the students. We have a video here that I want to show you in relation to it. I do apologize. There is a small amount of adult language in this. I think given the circumstances when you watch the video, it is appropriate probably. You can understand why the person says it, but I just do want to give you fair warning on that. And this is what, you know, we kind of call a botched go around. This is a video that those of us in the safety program have been using for a little while. And particularly what I want you to look at is not only how quickly the nose pitches up, but also take a look at the rudder in this. And I'll probably play it a couple times. And for some reason, so I'm going to go ahead, I'm going to bring in full power. So you can see the nose comes up very quickly in an event like that. You can also see the right turn or the left turning tendencies starting to have an impact to it, you know, and that's an elevator trim stall where it's recognized and it's recovered from and done at altitude for demonstration purposes, you know, with a student. It's really tame compared to what it may be like in the actual aircraft if you have a problem developing. Now that was just my son and I out doing some proficiency back the other day, and he doesn't fly airplanes regularly, but he flies another type of aircraft. And it's funny because we did that and we did the secondary stall too, which is what we'll talk about next. And even though he flies gliders all the time, we did a secondary stall in an airplane, and he's like, oh yeah, I've seen and done this with an instructor before. This is familiar to me. And so, like I said, because we're focusing in on airplanes, because that's where it sits in the practical test standards, it doesn't mean that awareness of all of this is just limited to that aircraft category. Now, when we get into a secondary stall, this is out of the airplane flying handbook. You know, what we're talking about is abrupt control movements where you end up with an incomplete recovery of the stall, or basically you start to recover from the stall and then the person is scared or frightened or whatever, maybe because of proximity to the ground, and they pull back. Now in our testing of this and also in the demonstration, there's two variations to this that you might end up seeing. I mentioned like in the glider we'll do it, and in the glider there's no engine to help with the recovery. You'll see this, and I see it probably quite often in the Piper products, is also a secondary stall can occur by just the addition of power, you know, where the pilot does not sufficiently reduce the angle of attack and adds the power. You know, in a powered piston aircraft, you get almost immediate acceleration, which very briefly accelerates you enough to get below the critical angle of attack, the stall angle of attack, but then the prop wash over the elevator, typically, you know, there are T-tails too, but the prop wash over it forces the nose to pitch up, kind of like a little pseudo elevator stall aspect to it, and you end up in the secondary stall. You know, turbine pilots out there are very, very, very cognizant of this. Sometimes they'll see this from transitioning power pilots who have just ended up relying too much on the acceleration of a piston engine to be an important part to the recovery. If you get out there and do some training on unusual attitude recovery and with an appropriate instructor, they're probably going to drill into you that angle of attack controller is the elevator. You have to reduce the angle of attack. The other thing that we do end up seeing, and this is on the flight reviews and that sort of stuff, is people that tend to try to power out of the stall without positively reducing the angle of attack, through the elevator, that they've been flying their own airplane for a while and really haven't had people checking them or getting together with an instructor. What we tend to see is the variations is new nervous pilots tend to be the ones that will recover but then snap back into the secondary stall, where pilots that have been flying longer in piston powered aircraft probably tend to rely heavily on the power. And it's not a comfortable feeling. You go and do an unusual attitude recovery course or something like that, hopefully, and it should be, if you got the appropriate aircraft, you take a look at stalls in vastly different attitudes. One of the things that I've almost always done in teaching, unusual attitude recovery type stuff over the years has been being on a downline, installing the aircraft. This is very exciting to someone that hasn't seen it before, but it completely makes sense when you go through it with them. But being on a downline, installing the aircraft, that you're 90 degrees nose down, you pull the nose up to say, 70, 60 degree angle sharply and suddenly, and it stalls, and you have to go back close to the 90 degrees down, to recover it. And doing it on an upline is, you'll hear some interesting names for those, which we'll talk about here in a little bit. Accelerated maneuver stall is the next one. This is right out of the airplane flying handbook also, but basically what we're looking at is stalling at greater than 1G and developing the ability to instinctively recover. Like I said, we see that on the commercial PTS with it, and it is in both the multi-engine and the single engine practical test standards. So an important part to think about with this, because it does have some added risk. It is dependent upon your aircraft on how much with it, but you definitely want to take a look at Appendix 6 of the ACS on the safety of flight issues with it. And this is what it has to say on it, is, that you really should be doing this at or below VA. Initiate stall recovery procedure at the first indication of a stall. Reduce the angle of attack. Don't try powering out of it, which is the issue we talked about on the secondary stall, because especially in a multi-engine, you can really throw in some significant yaw quickly if you have an asymmetrical thrust issue. Delaying the power application, assuring that you're above VMC, and this is something that we're looking at. We used to have this, actually, believe it or not, in the ATP practical test standards, where we had specified values for altitude loss and that sort of thing. And if you go back to those pre-stall and post-stall variables, all of those have factors on how much altitude you will end up losing in a stall recovery. Given certain conditions, you may only lose, say 50 feet. Given other conditions, you may lose 300 feet in a stall recovery, all in the same aircraft, but in completely different conditions on altitude, weight, power applications, control inputs, configuration, all of that. What it goes back to say is, there's a multitude of external and internal variables which affect the recovery altitude. And that goes right exactly back to what we talked about earlier on those pre and post stall variables. So an accelerated stall coordinated. In the practical test standards and in the ACS, you're basically going to be doing this at 45 degrees of bank. Yeah, I would consider that a little bit on the shallow side to make a prominent point. So, I would probably encourage, as an instructor, if you got the aircraft capabilities and comfort, maybe think of doing it up to about a 60-degree bank turn or so. And here's one of the classic questions. We're going to do another poll question here. Here is one of the classic questions that we will ask on a flight instructor practical test. So I just launched that. John, I'm going to ask for your help again.
You betcha, buddy. Here we go. The question: you stall the aircraft in a coordinated 60-degree steep turn to the left. Which way will it spin? Choice number 1, left spin. Choice number 2, no spin. Choice number 3, right spin. Choice number 4, over on its back and an inverted spin. And choice number 5, why? So go ahead. Once again, click on your answer and let us know what you think.
And we're just passing through 50% of 316 plus people. We're getting a bit more variation in this, aren't we?
Yeah, we are.
If you can see it, John, but we'll show it to all of you here in a moment.
Yeah, I've got so many things open on my screen right now, Steve. I'm afraid to click on the button for that one because it'll all blow up.
All right, we're passing through 1 minute. We got over 75%. Last chance going. 3, 2, 1. We'll close it out and we'll share that with everybody. And again, I'm going to need your help with the sharing.
You bet.
There we go.
Okay. I'll read them in order. I'll read them from the highest percentage to the lowest percentage. So you stall the aircraft in a coordinated 60-degree steep turn to the left. Which way will it spin? At 44%, we have no spin. At 24%, we have a right spin. At 17%, we have a left spin. At 15%, we have over on its back and an inverted spin. And Y comes in there again at 1%.
Yeah. And I specifically put the why in there as that last question because what we usually get when we're doing like flight instructor practical tests and things like that is we do get a fair amount of variation, as we just saw there. And usually our follow-up question to it is why. And that's the question that we're trying to use the demonstration stalls is to help you understand why. Now, I am happy we had the largest percentage answer that question correctly, which is no spin. Is if you are in a coordinated turn, that aircraft will stay in that bank angle, and you just relax or forward on the elevator to reduce that angle of attack. You'll start flying again right at that same bank angle. And that's a very important point to make. And that's exactly why we're out there doing coordinated stalls, accelerated stalls, coordinated. That's what I was looking at, is up there on the screen, is to show that to you. And also, as we look at the elevator trim stall and the pre and post stall variables and the things associated with it, what are the things that will introduce a yawing moment to start to cause that aircraft to maybe enter a spin when you do stall it? So this is one of those things I would encourage you, go out, find a good instructor and take a look at this and maybe practice some accelerated stall, especially those of you that, deep in your mind or thought that it would spin one way or another, or, over onto its back type thing. It's actually not bad. It's not something you have to be afraid of, or think that it's this voodoo thing out there. What it is it's very important on what inputs you have on the aircraft, both before the stall and after the stall. If you have appropriate ones where you're coordinated, it's not going to do anything. And I know there's actually some, I know like with SAFE, the Society of Aviation Flight Educators, they've done some videos distinctly oriented towards this that you can find on YouTube, you know, to help you out. And what we're looking for with the instructors, or I got one other thing to jump into here, is do recognize and think about this, is there is a bit of a difference when we're looking at accelerated stalls in a vertical plane, up or down, or up line or down line, like you see at an air show, versus those in a horizontal plane as we're flying, you know, left or right, is because of the load factors that are prominent on an aircraft. Almost all aircraft are not necessarily designed for it. And you'll see manufacturers saying certain types of stalls are not allowed. You'll see, you know, Cessna uses the terminology whip stall. Diamond Aircraft uses the terminology dynamic stall. You'll hear them called also aggravated stall or zoom stall. Now, as I did mention, you know, a lot of this is appropriate for a lot of different categories of aircraft. And the next thing is a short little video. This is actually a hang glider, but it makes the point. And this is what we call a zoom stall or a whip stall. And this is something that for those that fly the weight shift control aircraft out there is a very, very dangerous thing. So we're going to go ahead and take a look at that. Now, think about this in an airplane. It's thinking, it's thinking. It's still thinking.
It thinks about as fast as me, I've noticed.
Yeah, it is. It is. I'm wondering, usually it comes right up, but this, I'm still staring at a black screen in relation to that. Well, maybe we're not going to see it. There is the, I do have on this one for those that are watching the recording of this after the fact. I'll try this again. That I do have the address for it, and you do have that ability if you want to click on that. I'm going to hit stop on this. Let's try this one more time. Think, 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 just like Winnie the Pooh. Yeah. We all occasionally face glitches in our lives, and looks like maybe tonight we are facing one on this. I'm going to try one last thing, John. I'm going to change you over to the presenter and see if you can run it.
Alrighty.
That work?
That sounds good to me.
I'm making you the presenter.
Okay, here we go. And which one was it, Steve? Which?
It has whip stall in it, I think. Hang glider whip stall.
Yeah, I got it. Okay.
Excellent.
Let's see if we can get it to run. It's thinking from me too.
It is. Excellent. Excellent. Well,
yeah,
okay.
It doesn't look like it's going to cooperate today.
Okay,
I'm going to send it back to you.
Excellent. Thank you.
Yeah, here you go.
And 1, 2, 3. Let's see, what do we have? Waiting for it. There we go. Well, I'm going to leave it on here. If you want to take a look, I apologize that that's not playing, but it is a dramatic thing. And like I said, think about it in relation to an airplane if you were facing this. And there is the address for it so that you can take a look at it. It's a regular, just old YouTube video. It's only about 25 seconds long. But what we're really looking for in all of these things that we're doing is that a flight instructor understands the flight envelope and where things occur, and accelerated stall, where that ends up occurring, and how that you can stay safe in the aircraft. If you're not familiar, I don't know, this is not necessarily a specific aircraft, at least that I'm aware of, but I do know, taking a look at this, that this is an aircraft that is certificated in the utility category, which is the type of stall or type of aircraft that has a capability to go ahead and be certificated to be able to do spins. So that's what we're looking for. You know, does a flight instructor understand this regime and where it can go? You know, when we do a horizontal accelerated stall, you know, at say 60 degrees of bank, what we're looking at is the stall occurring at a load factor of 2 degrees. If we do it in the vertical plane, what can happen is we now have the change in direction of flight, and the amount of nose down recovered for the stall recovery is basically proportional or directly related to the amount of nose up. So if you bring the nose way, way, way up high on the stall, you're probably going to have to, in your aircraft, bring it way, way down. And that's one of the things that is shown in that. And what can happen in those circumstances is you go from a large positive G to a large negative G, and the aircraft are just not designed to withstand the negative G's anywhere near as well as the positive G's. And you can end up in this area of structural damage or much, much worse. We also want to make sure that, you know, student and instructor understand the impact of it. If we are doing a horizontal plane accelerated stall at, say, well, 45 degrees of bank is where we end up doing it. You know, what we're going to look at for a load factor is probably just about 1.3 degrees or so. And we're going to see maybe about a 20% increase in the stall speed, you know, that is showing us. Now, granted, you may be dealing with instrument errors also because you're getting at a larger angle of attack. But even an aircraft, you know, that stalls at, say, 50 knots in, you know, straight and level 1 G per second deceleration in doing the stall, what we kind of all are familiar with in our training, you know, 20% increase is only, you know, going to bring you up to 60 knots on the stall speed. It's going to be pretty small variation, you know, between 1 and 1.3 Gs and 50 and 60 knots on the stall speed. That's what we're looking at in the testing. But you'll notice that as you get to larger bank angles, this gets pretty high pretty darn quick. You know, as you end up at 2 Gs at a 60-degree bank turn, we're all familiar with that, but your stall speed is increasing by like 43%, you know, in relation to it. So we're seeing a pretty significant increase. That 50 knot stall speed at level at 60 degrees of bank in that same aircraft is going to be up at like, you know, low 70s, doing public math, 73, 74 knots, I would assume. I hope I'm right. Now, as we depart, just a few things. I hope tonight has helped you understand, you know, demonstration stalls, what they are, how they're related to safety and loss of control, what you want to be aware of that exists in the practical test standards in the ACS. And it is a little bit different. For flight instructors, we're looking for them to do the proficiency stalls and have instructional knowledge and be able to do the demonstration stalls and have the instructional knowledge of them. At the commercial level, we're looking for the proficiency stalls and the accelerated stall as a proficiency maneuver. And we're hoping that, or we expect, I should say, that the person have the stall spin awareness associated with the other 3 demonstration stalls. That's the cross-controlled, elevator trim, and secondary stall. And we saw that in the risk management. And the same thing in the private. we expect them to have knowledge of it in a risk management perspective of the 4 demonstration stalls: elevator trim, accelerated, secondary stall, and cross-controlled stall. And what we should be testing when we go out there, what is within that, what we're expecting of the instructors, and also in terms of teaching, whether you're an instructor teaching your students or whether you're a student being taught, look at variations in the demonstrations of the stalls that you do, those pre and post stall variables, and look at variations in it also in relation to the demonstration stalls. We talked about the secondary stall, how there's kind of 2 variations that you'll see with it, kind of the reduction of angle of attack with a sharp pullback, or kind of relying upon the power, i.e. trying to power out of the stall, and what the dangers are with that. In the elevator trim stall, take a look at it with a good and qualified instructor at a high enough altitude, within the limits and recommendations of the aircraft you're doing the training in. But do the elevator trim stall where you do the demonstration failing to apply the right rudder to correct for the left turning tendencies. Do another one where you do remember the right rudder, but don't necessarily remember the pitch, and see how fast that comes up on you. These are all the things that we want you to explore to help you be a better and more proficient pilot. The last little part of tonight, is we always do advocate for you to be a proficient pilot. If you're not involved in a wings program, please, or if you're not involved in a proficiency program, please do get involved in a proficiency program. If you don't have any readily available to you, we do have the wings program, which, all you need to do is create an account, do your profile, and you can start attending the seminars or webinars like us, like we have tonight, and also start doing the wings flight programs. I just did a couple of them, John, right? No, actually, you didn't even, many times you will approve credits for me, but the last 2 flight credits I got, you did not approve.
Yeah, you didn't send them.
Yeah, the flight instructor did it and used the flight instructor portal, which I'll talk about here in a brief moment. But excellent. We do ask, fly regularly with your flight instructor, work on perfect practice, and document in the wings. We want you to be good, safe pilots. You can't complain when people like us tell you that you need to go out and fly more. I know I tell that to my family all the time, and if you're not familiar, this is great for the instructors, but also if you're not an instructor, if you want to get wings credit, this is the quickest and easiest way for any flight instructor. They don't have to even be in the wings program. If they hold a valid flight instructor certificate, they can use the instructor portal. And if you go on the Boston FAASTeam YouTube channel, there's a short 8-minute video on how to use the instructor portal, which is terrific. Now, here's our contact info. If you have any questions following up or whatever, there I am, my address, email. I'm going to mention John, goes by Dan Carter out in the Bradley FSDO. He's out with that group tonight in Worcester, Mass, where they're doing that kind of live presentation. And then there's your contact info, John.
That's me. That's when I was young and good looking, Steve.
Yes.
Not anyone.
Notice I'm wearing a hat and sunglasses and trying to hide that now. But I want to thank you all today. We're going to stick on to take some questions. You don't have to stick on. If you did register for this with the same email address that you use in the Wings program, you will see in the next few days Wings credit being applied for this. We do want to thank you. You are the special ones out there because you care. You're here with us tonight and learning, which is important. So I ask, invite a friend to a seminar, to a webinar, even take a friend flying. you know, it'd be a terrific thing. So thank you, everyone. I do appreciate you joining us tonight.